I was asked whether I'm with Oak Ridge National Laboratory. I'm not. I'm doing a lot of things in Germany. This is what you're going to miss if you don't go to the Stuttgart end of October. A number of nice things and a lot of entertainment. Now for the first part of my talk, I'll talk about Germany a little bit and about HLRS. I will not say what HLRS is doing, and I'll not talk about our systems a lot. Keep in mind we are the most important center and we have the most exciting system, as everyone has. And we do big data and cloud and so on. I looked at the trends in Germany at the top 500 list, and what you see is that we have less systems and less performance. That means looking at the top 500, I'm not so happy with what is happening in Germany. And I looked at what the reasons might be, and I came up with some explanations, like more competition in the top 500, because in 1993 people were not that much interested, but actually it's not really true, but maybe. More national projects around the world, that's true, but only China is really new. I mean, we have the US projects and we have the Japanese projects. And there is some Russian project, and I recently heard about a nice system that is going to be available next year or so. But only China is really new. More industry, because some people claim that the industry share in the top 500 is growing, but that's not true. If you look at the top 500 list, you see a fluctuation and you see the number of industrial systems grow and shrink, but that's not the reason. There might be other reasons. One is that we have some funding problems. We changed the constitution in 2006, or the Germans changed the constitution in 2006, which basically did not allow to do a federal and state co-funding anymore. And everything that was HPC was co-funded by federal and state government until 2006. So we ran into certain problems with the constitution there. The second point that is interesting is that we implemented a focused strategy, slightly following the US with their national centers, slightly following the Japanese approach with their one-of-a-kind, single, outstanding, blah, blah, blah centers. As a result, we have 3 centers in the Tier 1 capability, as we call it, and we have a number of regional centers, but we have a general trend to concentrate resources in a few places, which is sometimes good because you can pool resources and then you can have faster systems or bigger systems. Usually it's bigger systems and not faster systems. And there is no such thing as what we see in some places like the US and China, that universities invest a lot of money. And the reason for that is that universities in Germany usually don't operate large-scale facilities, and they don't spend a lot of money for hardware, at least not in HPC. And then the other reason is that computational X, physics, chemistry, blah, 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 is not as strong as the old sciences in Germany. So Germany is pretty much an old country. And I remember that there was one US politician who said there is old Europe and new Europe or something like that. Okay, Germany is definitely old. And this is how HPC is organized in Germany in general. There is something which is called the Gauss Center, and they operate Tier 0 systems and Tier 1 systems. Tier 0 is European level. Means every European has access to the systems. Tier 1 means it's German. And then we have what we call the Gauss Alliance. I'll say a few words about that later, with Tier 2 systems. And then we have these regional sites where we have clusters of smaller systems, and everything seems to be well organized. And then you have data management, but we haven't yet decided how to do data management. And Germany has not yet understood that data management or big data is not about storing data, but about analyzing data. So we're still discussing how we store the data, which is a stupid question. We do have a national research network, and we have some software initiatives, and I'll say a few words. Now, organization-wise, we have this Gauss Center for Supercomputing. This is 3 national centers, one at Jülich Supercomputing Center, one at Munich, Leibniz Rechenzentrum or Leibniz Computing Center, and HLRS, one at Stuttgart, High Performance Computing Center, Stuttgart. We do have a head office. We have a CEO, in a sense, or a director. And we have 2 offices, one in Berlin and one in Bonn, and the director is neither in Berlin nor in Bonn. He's at Aachen, but that works well out. If you need more information, go to gausscenter.eu. And then we have the Gauss Alliances, which is 17 members, of which 9 are regular members and 8 are associated members. And they exist since 2009, but it took them 5 years to set up a head office. And we're starting to set up that head office this year, and I hope we will have a director maybe in 2015. Again, you just look at the web page. Software research activities are not that well supported as they are in the US, for example. We have basically two funding agencies. One is what is called the BMBF, which is the Federal Governments of Science and Education, and the other one is the DFG, which is the National Research Whatsoever Community, just like the National Science Foundation. Yeah. The Federal Ministry funded 26 projects related to supercomputing software development starting in 2007 and 2010. We're currently negotiating to get an extension of this program and a third funding period. DFG started a special program, Exascale software program, back in 2012, and the project started running in 2013. Currently 13 projects, 2 of them are with HLRS participation, and we're currently expecting a second call, and this program will run until 2018. Some strategic measures for Germany. First of all, we changed the constitution. For me as an Austrian, it's more difficult than it is for the Germans, but we worked on this, we spoke to politicians and everything, and the federal ministry recently announced that they want to change the constitution, which is good. So we have this majority, we can change the constitution, it's not the problem. Then we are looking for a global national strategy currently. From time to time, you need a new global national strategy. So we had 2 working groups. One was a working group that finished their work on simulation in 2014. The report was released. Nobody knew about the working group, and everybody was surprised about the report. But it's supposed to coordinate supercomputing. Okay. The other working group everybody knows about is the working group on funding for HPC. This working group is still working, so there is very little I can say about it. Basically, the idea might be to coordinate everything from tier 0 down to tier 3, but this is not yet decided. Then there is another strategic approach, which I call Europeanization. If we can't afford to compete with the US and China, as Germans, maybe we can afford to compete with the US and China as Europeans. We are currently discussing a continuation of PRAISE, because PRAISE will stop its first phase in, I think, March or April 2015, and we are working on a continuation of that phase. So Europeanization is probably a long-term strategic activity. I may report in 10 years from now that Europeanization has led to some results. And then there are funding strategies that we are discussing. The government starts to understand that you don't buy a system and then you have an inauguration procedure and then you walk away and come back 5 years later. There are still some operational costs, and they start to understand that we need funding for operational costs, for staff costs, and for maintenance costs. That's good. That's very good. And especially the government of the state of Baden-Württemberg is very open to this. So what is going to happen in the future if you take all these strategic directions and you know where you're headed? The Gauss Alliance funding has been approved. There will be 25 million euro per year for the next 5 years. What has not yet been decided is who will get the money. So you have seen there are 17 centers and there is 25 million euro. Over 5 years, it's 125 million euro. There is 17 centers, so everyone gets 20 million euro, roughly. Okay, that's what everyone thinks, but somehow the math doesn't work out. So we will have to see how this works out. At the same time, we're discussing with the federal government and the state governments about continuation of the Gauss Center for Supercomputing. I expect that we will find an agreement within these 3 state governments and the federal government. We are very close to getting a decision, and all of the 3 states are very positive about it, so that should be not a problem. We will put an additional focus in that next phase on user support, on training, and on industrial usage, with each of the 3 centers having a different scope and focusing on different issues. There are some open issues. One is the integration of the Gauss Center and the Gauss Alliance into a single German infrastructural HPC environment. there are basically two opinions. The Gauss Center thinks that we are working well and we don't need another 17 partners to discuss with us. The other 17 partners thinks that they should join our project and get a share of the 400 million euro that we expect. We will see how this works out. We are trying to coordinate activities for the funding of software development. As in the US, you have different organizations, different agencies, and they are not always well organized. But we will have to see. And the really big issue is the European strategy. Everyone is still expecting a lot of money from the European Commission, but the budget of the European Commission was cut. And usually when there is less money, then it's more difficult if you don't have a real plan, if you don't have a real concept. There is very little chance to get additional funding. The most positive thing about the European arena is that the German commissioner, Mr. Oettinger, was previously the Prime Minister of the state of Baden-Württemberg, and he is now in charge of these things. So I just learned this last week, so there may be a chance to improve the quality of the work there. Okay, any questions about Germany? No, thank you. I didn't expect any. HLRS, a few words. This is still my strategy. These are I call this the octagon of the HPC director. These are the main questions that you have to answer. Organization, infrastructure, hardware, software. We have done this for a long time, and each of you has done this for a long time. That was something that was important, say, in 1990. Then research and economy is the collaboration with industry, something which was important in 2005 for us. And until 2020, we want to establish closer links and a better collaboration with society and politics. How do we do this? Well, we have systems. Everyone calls it flagship system. I don't know why the word is there. I did this slide, but okay. We had a Hermit system, which was 1 petaflop in 2011, and then 2014 we're currently installing a Cray XC30 called Hornet. You see the Hermit beetle and the Hornet is an enemy of the Hermit, which I like very much. And then I decided that we are going to have an upgrade in 2015, which I call the hazel hen, because hazel hens eat hornets. I don't know yet what to call the next generation system that will come in 2018 or 2019, but I'll find a nice word, a nice animal eating hazel hens. The performance is given there. It's roughly 3.786 petaflops of peak and 600 teraflops of sustained, which was the most important point in our procurements. We are currently in acceptance tests. Things are going quite well. Energy consumption is acceptable. Cooling is okay. There is a problem with MPI latency, but we will fix that problem. And we will double the system, as I said, in 2015 roughly, and then it'll be 7.4. I'm still doing well on the time, right? Thank you. Okay, these are the systems. None of these systems will ever be top 10, obviously. I don't care about the top 10. In the top 10, you'll find all the systems that... where is the guy who was talking about Roadrunner? No longer here? In the top 10, you only find systems that are a huge success, like Roadrunner. Okay. Okay, on the right, you see the usage of the systems. We ended up in the last months to have usage in the range of 98 to 99%, and I'll say a few words how you achieve that. We do industrial customers. These were the customers in 2013, and the slide yeah, this should give me light. This one here is our annual turnover. It was 2.2 million euro last year. It's going to be 2.4 million this year, which is good because we make a lot of money. This is my favorite industrial project. It's a movie which was done by an Australian and a German company. It's called Maya B, I think. And it was released on the 11th of September. And this is the reason why we had the high level of usage. Because they do pictures on a single node or even a single CPU. That means you can just fill up your system with these stupid jobs. and that gives you 99% of usage. And for me, this is one thing that is important. 10 years ago, there was a competition between industrial usage and scientific usage. This is no longer the case, because the industrial jobs are so small and the scientific jobs are so big that you can just fill the gaps with the industrial jobs. And still the industry is happy to get access to something like 10,000 cores, and the researchers are still happy because they are not disturbed by industrial usage. This, for me, is something which is very important. Another thing that is important is training. We will build a training center. We started to do this end of this year. I hope in December. Unfortunate thing is that we have to pay for it, which is 6 million euro. And it takes a long time to do this, but then the building exists for 50 years or so. And the successor of my successor will then have to deal with the building. It is a training that we do good, and it is sufficient. I show this slide because it gives a comparison of all the European countries and about the amount of training that you give for every 1,000 students in math, natural sciences, and engineering. The Germans cover about 4.2 students of every 1,000 students, and of this, one half, about 50 to 55% is HLRS. So HLRS is covering 2 out of 1,000 students of math, natural sciences, and engineering. And you see, the only country that is doing better is Finland, better than HLRS. All the other countries are worse. So I'm happy with that. A few other topics. I will install new working groups at HLRS, one which will do industrial training. We understand that industry needs to understand that simulation makes sense for them. So far we have worked with companies that already know that they need simulation. In the future we want to train companies to understand what they can benefit by using supercomputers. And then I have decided to create a working group that is called Accompanying Research, Accompanying Social, Scientific Research whatsoever, which will cover all political, sociological, economic, and philosophical questions of simulation. This is very interesting. I think it is important. We increasingly get to see newspaper reports about simulation that basically deliver pure nonsense, but unfortunately I get to see scientific colleagues that deliver pure nonsense based on simulation that don't make any sense. You can put this on the webpage if you want. We don't have big data, we only have data, and we're currently working in the state of Baden-Württemberg to find a solution for that. The main problem being, as I said, that it's not about storing the data, it's about refining your data. Cloud, yes, okay, everybody does cloud. We do it with T-Systems, and we do it with projects funded by the European Commission. This is where the European Commission is, by the way, very successful and very useful. This is our timeline, which from time to time I show. It's hard work to build the new building because it takes a lot of time. One issue that is relevant is I have heard about vector systems, and where's the guy from Intel? I visited Intel in 2001 and I asked Intel to implement vector features on Intel processors, and I was told it's, first of all, it's stupid, and second, it's not possible. So I'm very happy to hear that it's not stupid and possible. But anyway, we are going to... Thank you. You're not the only one. Also, IBM told me it doesn't make sense. And NEC told me it doesn't make sense. So pretty much everyone knew that vectors on microprocessors don't make sense. Anyway, we'll have an NEC vector system installed at our center at the end of this year. We still think it's a relevant architecture. What is this? Ah, yeah. Cray is going through acceptance. This is nice. Long-term basic research is okay. We're struggling with small and medium-sized enterprises. This is a permanent activity. There is never going to be a solution where you say, okay, I fixed it once and forever. So that's a lot of work. Yep, and the other thing is that motivated by the BMAIA activities, I decided to set up what I call a media solution center, working with a lot of the small companies that do a lot of work in movies, PR activities, and things like that. And with that, there is roughly 1 minute left for your questions. We're running late, so I appreciate if you don't have any questions. Because I think the presentations after the break are pretty interesting.
I have a very quick question for you.
Sure.
I was wondering, when you're talking about the complexity of the 27 countries and the long proposal documents, if perhaps that could be treated as a big data problem and supercomputing could be used to refine and get the answer to that question.
I think that's a very interesting approach. If we could set up a project that tries to find out how we could do this, then we could postpone further praise activities for the next 5 years, which would leave us enough time to do our work. Thank you for the suggestion. Sure, Susie.
Michael, a quick question for you. You talked a lot about, or mentioned several times, small and medium-sized businesses. One of the things that we're finding related to industry is small does not necessarily mean inexperienced, and big does not necessarily mean experienced. Right. And I'm trying to personally train myself to start talking about inexperienced versus experience. Yeah. Are you seeing in Germany, though, that really the inexperienced is more collected down at the small business level, and that your larger companies...
No. It's the other way around. You typically find expertise in the smaller centers, smaller companies, because these smaller companies exactly know what they're doing, while larger companies basically behave like large government organizations. So it's very hard to find the competence in a large company. I'm not saying that there is no competence in large companies, but...
Do you find that the large vendors in HPC are more or less willing to innovate than, or innovate for the things you need than 10 years ago?
Two comments on this. Don't want to answer the question. One comment is that there is no large companies in HPC. There are small companies that are part of large companies. This is with IBM or NEC or something like that. And there are small companies that are not part of big companies, which is Cray and T-Platform. So all HPC companies are small. It's the same with Intel. I mean, remember Intel Paragon, one of the most successful systems, and then Intel decided we're no longer interested. So this small HPC company called Intel went away. Innovation. I think that the people in companies are still interested in innovation, but the market is no longer there. I personally believe that the margins are so low that it is very, very difficult to find the money to do the innovation that is needed to really improve things. Everyone just tries to do incremental because there is an extremely high risk. The margins are low. The more money you put in, the more difficult it is to get the return of investment. So people try to put in as little money as possible. And that means you only get incremental improvements. And I think that's the reason why we see so many different architectures with people talking about FPGAs and NVIDIA graphic cards and Intel 5 processor and everything. I don't expect big innovations over the next years. I think there is not the business model. There are technical people who know exactly what to do, and to say something positive about Intel, there are brilliant people at Intel, but unfortunately, they are not making market decisions. They are not making business decisions. They only can do technical decisions, and I don't think we're going to see someone like Seymour Cray who says, I ignore the market and I just do the best technical thing that can be done, and then I hope that someone will buy the system. I don't think we will get to see the same situation where there is enough enough money in the market for those people to survive. Welcome. I'm looking forward to the next presentation. So thank you very much.